Okay, hello everyone. Another session. Today we discuss module number 3, Introduction to Networks, Protocols and Models. As I was saying, this is a critical chapter because networking, by definition, it is as much based on anything but protocols. And what is a protocol? Basically, protocols are rules. That's the simplest definition that you can have. Rules that govern how data is being exchanged between two or more devices. Our definition of networking probably stems from understanding what is communication is, because networking is an interconnection of devices with the sole goal of sharing information, exchanging data. There is need for more rules of how that data is exchanged. For example, if I start speaking French right now, probably a number of you won't understand. Rules of communication say we have to be speaking the same language. If we are not speaking the same language, something will be lost in translation. Those are the rules of communication with us humans. Devices, networking devices to be specific, they also have rules of how they are supposed to communicate. And that is what we call protocols. So protocols enable communication, ensuring that devices can understand and interpret the data that they transmit and receive. At the same time, it also ensures standardization. I think we are going to be looking at what we call standardization, which is just providing a common language for devices from different manufacturers. The reason why, even if I'm using a Dell laptop, I'm sure there's someone with an HP laptop, there's someone using his iPhone, MacBook, Android, whatever it is. The reason why we can communicate is because of standardization. And the reason why it's easy to have standardization is because of the protocols that we have in networking. And the protocols, like I said, they are just rules. And I think that is the basis of understanding that you need to understand protocols, rules of communication. Right. Now going to models. A model is, if I can say, just a framework, a conceptual framework for understanding or breaking down complex processes. Networking as it is, it's a complex process. It's not that easy to understand with networking. I think by definition, the boneta is that we're just sharing information. But how do you share information from where I am to someone are in Europe? That's a complex process that is happening there. So to make that complex process much easier to understand, we have my models, which are conceptual frameworks that we're going to be using so that it becomes much easier to understand what networking is. So today we are going to discuss those protocols and those models. Right, going to our objectives. Our main objective is to explain how network protocols enable devices to access local and remote network resources. We will describe the type of rules that are necessary for successful communication, explain why protocols are necessary, explain the purpose of adhering to a protocol suite, explain the role of standard organization in establishing protocols for network interoperability. Then we'll look at explaining how the TCP/IP model and the OSI model are used to facilitate standardization. Explain how data encapsulation allows data to be transported over the network. Then lastly, explain how local hosts access local resources on a network. Right, the rules. Uh, Communication protocols, it is not enough to have a connection. Devices must agree on how to communicate. Like I was saying, devices must agree on how to communicate. Those are rules of communication. agreeing this is the way we are supposed to communicate. So you see that protocol account for one, an ID for the receiver or the server. A protocol defines Diana Rufano send a data, Diana Rufano receive. That's why we have, for example, an IP address. IP standing for Internet Protocol. It's a protocol IP, right? Which is responsible for identifying who is the sender and who is the receiver, right? Two protocols, we have protocols which are responsible for accounting for speed and timing of delivery. And when we talk about speed and timing of delivery, we have some applications that require real-time delivery. For example, this one we are using, it requires real-time delivery so that zvinhu zvandiri kutaura this end, you're supposed to be hearing them probably with the minimum delay. That is real-time delivery. There are protocols which are responsible for that. For vanhu vakatifambei kumberi, we have a protocol called TCP. It is responsible for real-time delivery. That is the one that we use, right? We have UDP as well. We have UDP, another protocol, which is used for delivery as well. But taking into consideration applications which tolerate, which also tolerate delays. For example, WhatsApp. I think there was a point when I was explaining the difference between the real-time traffic and the one which has delays. WhatsApp, when there's a message, kusina network. Inogona tick one, or I say anything. There's like a clock. That is the type of traffic tolerate a delay. So no problem. Paunodzoka network inenge yapo. There are protocols, rules behind everything that is happening in communication here. So we also have my rules of acknowledgement, which allows us to that message yasvika. So we can send a message. I think WhatsApp, another perfect example. We can send a message in as a blue tick. Blue tick is not that message yasvika. Probably a deliver in the one, right? There are protocols. Those are protocols which are in action behind the scenes. Then we have common language and grammar. So when you talk of common language and grammar, I think the perfect word for that, we have encoding and decoding. Changing the format of a message so that we can transmit it over the channel that we want to transmit. Then on the other end, decoding. Common language and grammar. So you might have one device speaking language X and another device speaking language Y. If they want to communicate, what encoding basically does is convert the language X into a language which is understandable by device Y. So different devices, different manufacturers, different languages, different grammar. What makes it easy for those two devices to communicate is protocols, the rules behind. And some of the rules for the last one in common language, we have what we call encoding and decoding. I think we're also going to be looking at that. Tikatarisa padiagram apo tine tuma messages atinawo. The importance yemarules. Tine tuma messages atinayo. Humans communication between govern rules. Grammar, not proper. Right? But rules of communication says, kana tichitanga sentence, tinotanga necapital letter. That's a rule. That's why pane capital letter apa hapana. So this guy up the whole message, which is a bit not okay. The first one, this one is more proper. Ndikutoona kumberi kwakaiswa neimwe language. I don't know which language is this one. You will not be able to understand language iyo kana usingaisiyo. You need a translator. A translator, that's a protocol kana tiri networking. That's a rule. So a protocol is a rule which helps us to make communication easy for us humans and for devices in networking. Right, now going to encoding. I think I had already defined that. Encoding, process of converting information into another acceptable form for transmission. Messages sent across the network are converted to bits. Bits are encoded into a pattern of voltages, lights, or microwaves. The destination host must decode the signals to interpret the message. So encoding is basically the process of converting information into another format, from one format into another, ensuring that it can be transmitted reliably, efficiently over a specific channel or medium. Specific, why? You can see panapa the bits. We have a message. Let's start with the message. Message irutangira, for example, ndine transmitter kuno. Message yangu irutangira voice round, right? Yotorwa mic, laptop, voice. It is converted into something. It's not the voice which we are going to transmit wirelessly over the medium air or ichazopinda fiber over the way kuti isvike kwamuri ikoko. It's not that, right? How is my voice transmitted? My voice is converted into a format which is transmissible over a specific medium. So, like I was saying, example of voice now, I know it is being changed to microphone, change that voice into a voltage, right? A voltage that is encoding. Then that voltage at some point is turned into digital format, binary, doma bits are. That is encoding as well. If transmission is wirelessly, it will need to be converted into an electromagnetic wave so that signal if it is converted via fiber, signal they will need to be converted into light so that it can be transmittable via fiber. If via copper, it needs to be converted again into voltages so that it can be transmitted over copper. So that is what we call encoding. And chikuita kuti uchinje chinoita kuti signal rizive kuti izvezvi medium yatichashandisa ifiber here, is it air or is it copper? Chinoita kuti muzive izvozvo ma-rules. Those are the protocols behind what we call message encoding. Right. Encoding as well can mean, for example, kind of security. A message will need to be changed, to be encrypted, if I can say. Encryption, that is a way of encoding a message, ensuring security. When you talk of encryption, when you talk of decryption, that is encoding in play as well. Examples, the encoding, ASCII. I think this is one of the most common ones. Let me see if I can write on my screen. I think you've heard of this one. This is one of the most common ones. So kuchinja signal kuendesa binary, that's a way of encoding, right? Decimal to binary. Encryption, that's another way of encoding a message, right? Encoding done. Maybe I had left out when message yasvika to the other end, it will need to be changed. Imimi chamuri kunzwa voice. Chandiri kubudisa kuno voice. But in between pakati pedapo, that voice is being changed into different formats, like I was saying. But parinozosvika ikoko, it will need to be changed into a format inokwanisa kunzika na receiver. That process is decoding. So on this end, the transmission tine encoding, on the other end, tine decoding. All right. To end up formatting and encapsulation. What is message formatting? What is encapsulation? By definition, a message format provides just a standardized structure for data transmission, ensuring devices understand and interpret the message correctly. A structure, a data structure. A perfect example is a letter wrapper. Pataita English. Ushinyora letter, maidzidziswa kunzi, is it on the right side or left side kunoiswa address yekuenda message, on the left side kunoiswa imwe address yekwairi kubva, then oskip one line oisa date, oskip another line oisa kana iri formal letter, application letter, oisa ref, you underline unoiswa nema-capital letters, oisa DSC or medium, oisa introduction paleta rako, then you have the main body, then you have the conclusion, oisa yours sincerely. That is a format yandakadzidziswa yeleta. Letter iroro kaenda risina format iyoyo, if it is an application letter, it means basa rinogona kushaika. It's the same thing in networking. If you send a message with the wrong format, the other end who receive a message might not understand that message, then meaning message inenge isina kusvika, basically. So formatting is very important. Structure your information which is being sent. So in networking, we have a format. On my right here, that is the format that's no chance of networking. As you can see, pane version, source IP. I think this is a packet, right? This is a packet. This is a data packet. Data packet is in a structure yayo. We'll define a data packet with chi, but this is a data packet. And then structure yayo. Structure yayo, you can identify it by the destination IP address, source IP address. Ikasendwa packet risina format pasina source IP and destination IP. Then it has the wrong format, meaning receiver, when I receive information, it will not be able to interpret message sendwa because per format, structure-wise, something is missing. So message formatting is very important in networking. Message inofana kunge in a format is proper so that it can be easily interpreted on the other end, on the receiving end. Talking of encapsulation, encapsulation refers to the process of adding additional information to data packets as they travel through the network. Taking the letter as well as an example, kana uri kusenda that letter rinoiswa muenvelope, ukaisa bepero riregero pasi rinoiswa muenvelope, that message won't get anywhere. That is encapsulation kuma-letters aya. When we talk of encapsulation in networking, we have my headers, my trailers. We talk of my layers in networking. At every layer, when a message moves from one layer to another, a header and a trailer is added. That is what we call encapsulation. Per header and trailer papo, the opening information about that specific layer. We'll get to discuss that, I think, my slides are made. But for now, message formatting, very important. A message needs to have a format, a structure. A message needs to be encapsulated. Some information needs to be added through the message. So voice rangu kana riri kutransmitwa over a channel kuti risvike kwamuri, there is something that is added to the message in between me, the transmitter, and you, the receiver. That information which is being added defines the process of encapsulation. Right. Then we look at message size. Very important. It refers to the max minimum allowable size imposed on the message exchanged. The source host can break a long message into individual pieces that meets both the minimum size requirements, the minimum and maximum size requirements. So long messages need to be broken down to smaller pieces. A long message needs to be broken down to smaller pieces. Why? Number one, efficiency in transmission. Sending a very large message is very difficult because it takes a lot of bandwidth, right? Instead, you can break down that message. I think there's a pictorial explanation there. You break down that message into smaller pieces, which takes smaller bandwidth on a channel, meaning more efficient transmission, faster transmission. Also, message size helps in error handling. If you want to handle my errors, for example, there's a protocol TCP that you discuss. Protocol at TCP is mainly defined near to segmentation. Number one, breaking down a message. That is segmentation. Number two, sequencing. Numbering my messages are break down with message and get pamberi. So for example, pana message pamberi and doing get message number one. Let me see. All right. Sequencing is message number one, message number two, message number three. So that's akaenda mu channel. At some point, pamwe 3 ndio ichatungamira. Oenda akadai so. Message ikareceive yakadai so. Iyo yasendwa kubva kunoku iri 1 2 3. Kunoku yosvika iri 2 3 1. Kana pasina nyaya sequencing, it becomes a problem. We won't be able to understand the message. So the difference in two segmentation, breaking down a large message like this one into smaller messages, which makes for more efficient transmission, segmentation. Two, sequencing, numbering my messages are break down so that panosvika to the receiver, they are rearranged. So panosvika kana takaita sequencing 2 3 1 gets rearranged to 1 2 3 because we know my numbers how they are arranged. Right. So those two things defining the breaking down of a message and sequencing, it helps. Why? Because for example, kana takutaura nyaya TCP and nyaya reliability. Let's say one of the message anosvika number 3. Instead of sending the whole message again, you can send a message back kuti hatina kureceiva sequence number 3. Hatina kureceiva message in a sequence number 3. Then sequence number 3 is only sent. You cannot do that kana only one long message like this one. Ikasasvika, you need to resend everything. So that's a problem. You go on long messages. So message size is very important in networking. And what defines the size of message, say, are the protocols. Protocols are rules that define how networks communicate, how networks exchange information. All right, let's go message timing. With message timing, we have 3 things. We have the flow control, response timeout, and access method. Basically, the flow control manages the rate of data transmission and defines how much information can be sent and the speed at which it can be delivered. Flow control prevents the sender from overwhelming the receiver. That is basically what it does. Kana sender achisenda 1 gig per second, 1 gigabyte per second. This is the sender transmission. Receiver, portrait receiver, richikwanisa receiver 100 megabytes per second. Portrait kuno pusha 1 gig. Portrait ukwanisa kuaccepta 100 megabytes per second. That's a problem. Why? Because port is capacity show. It will not be able to take in 1 gigabyte per second. So what happens? Network inotanga slow down if we are being practical. There is congestion in network at this port. Because port is big. Network slows down. But when the network slows down, some of the information, some of the packets which are being sent, they start getting dropped. Road communication say so there are protocols which define alternative flow control. So if we were to have a protocol, protocols are not, like I said, it's a rule. Protocols are not pamunotanga communicate this port iri this port iri rinosenda kuti inini ndinoshandisa 1 gigabyte per second, indoshandisa 1 gigabyte per second, uyobva kuti inini ndoshandisa 100 megabytes per second, uyobva kuti 1 gig yangu yakawandisa, so let me reduce speed yangu ndisende at 100 megabytes per second. Thank you very much. I think tawirirana iwe unosenda at 100 because inini ndokwanisa accept 100 megabytes per second. That communication is exactly what happens in a network. There is a communication between my devices. Ndo anonzi ma-rules acho. I remember when I was doing CCNA, I had difficulty understanding with the protocol chi. Protocol is exchange yetuma messages itkoto. Like what I was just doing there. Communication yo yekuti hello, uyo respond hello, how are you? Uyo respond inini ndine 1 gig, uyo respond inini ndine 100. My devices are communicator. That is what we call a protocol. Until you reach a stage yekuti mawirirana as my devices, then we can start sending information. That defines what we call a protocol. Tichasvika paprotocol yese irimo muno. Okay, not yes, we might not have the time, but the most common ones. And I'll explain that exchange in my messages. Kuti protocol, what is that? It's just exchange in my messages between my devices up until you agree that this is how we are going to communicate. Right, response timeout manages how long a device waits when it does not hear a reply from a destination. So this one, it prevents indefinite waiting responses. Send a message, TXRX, send a message. There is no acknowledgement of the message yasvika. Pamwe message yacho yanotombosvika. Do you just have to wait? Also, kuziva kuti message yasvika here kana kuti yanosvika. We have what we call a response timeout. I think you've seen this. If you're trying to load a page, you're not going to response timeout sometimes. Why? It's a protocol rules information every message yanosvika basically. Message yanosvika tinokwanisa kusvika kwanga tiri kufanira kutora information. That's a response timeout. So there are protocols which define that. Kuti kana message isina kusvika, one, kana message isina kukwanisa kudzoka futi. Maybe yasvika but iri muroad haina kukwanisa kudzoka kuno. A response timeout is sent. Kana yasvika takuziva as transmitter kuti message yatasenda pamwe haina kusvika or we didn't communicate. Therefore, we need to resend. If you don't have my protocols, then communication becomes very difficult. Lastly, we have the access method, which determines when someone can send a message. At times, we have what we call a shared medium. We have what we call a shared medium. Shared medium. Right. A shared medium, regarding Wi-Fi, I think Wi-Fi used a shared medium. I think it would be difficult to understand that one. Let's go with the switch. Ethernet, shared medium. Ethernet LANs use the shared medium. And the switch helps us very much go these some problems which are caused by shared medium. By saying we have a shared medium, I think I once gave an example like that. So let's say we have PC1, PC2, PC3, PC4. All right, this is our network. My networks they are being connected by Ethernet. Let's say an Ethernet cable. They are in a bus topology. They are using a shared medium in the sense if this one sends information in an app, if this one sends, use the same medium. The problem with my shared mediums in my collisions, if 1 and 2 sends at the same time, we have a collision. So there are protocols, there are rules which says if we have a shared medium, how are we then going to communicate? There is one, is collision detection. I think the other one, is collision avoidance. Collision detection, basically, if one sends, collision detection, if one sends, inotanga kuti listen, kuti is anyone else sending per medium? If there is no one else sending per medium, then one, ndopa anokwanisa send. If 2 wants to send at the same time, pano listener to the medium kuti pane chiri kusenda here. This one responds kuti pane something chiri kusenda, then this one waits up until there's nothing else. That exchange yima messages yekuti mumedium mune chinhu here amuna izvezvi zvamusisina chinhu, so now I can send. that defines a protocol. Do not my rules of communication actually. So those three things define what we call message timing, which is very important for my networks, because without that, it will definitely be a disaster. We will not be able to communicate with the problem. All right, let's go to message delivery. This one is easy. Easy as usual, I'm communicating with, I think this is a broadcast, if I can say. I'm communicating with everyone that is joined this meeting. That's a broadcast. If you are communicating with every device in a network, that's a broadcast. If you are communicating with one device, that's unicast communication. If you are communicating with many but not all, then that's a broadcast. So I think my diagrams explain it best. Network managed in a form of PCs, right? This is the source, this is the whichever message here, transmitter, right? If I send it to one device, that's unicast. If I send it to multiple devices, but not all, these are multiple devices. I've sent to two, but not all of them. That's a multicast. If I send it to all the devices, that is a broadcast. This is very important kubata. Pachaita ma-addresses anosenda ku-multicast, ma-addresses anosenda ku-broadcast, anosenda ku-unicast, they will be very different. And understanding with unicast, broadcast, and multicast chi will help you define those addresses. Right, moving to protocols, network protocol overview. Network protocols define a common set of rules. We are past that. It can be implemented on devices in software, hardware, or both. They have their own function, format, rules, right? On this one, we are going to look at protocol types. My protocol, we have my types in my protocols. I think we can group them into those types. We have what we call network communication protocols, which enables two or more devices to communicate over one or more networks. And examples of protocols like those, IP, the IP protocol. It allows us to identify who is the sender, who is the receiver, therefore allowing us to communicate over one or more networks. With IP, that's a network communication protocol. With HTTP, pese pamuneza an address, your website, by Google, whatever it is, per browser. You are interacting with the HTTP protocol, which enables two devices to communicate. Tavanontara TCP, another protocol, which ensures reliability for communication here. Right? We have my network security protocols, which secure the data, secures data to provide authentication, integrity, and encryption. My network security protocols in CCNA, we are not going to touch a lot on those. We have a complete different course in network security, but some of them, so far, we have SSH. That's a network security protocol because communication yayo is encrypted. We have learned about SSH. We have SSL. We also have TLS, transport layer security. Those are some of the protocols, the security that we have routing protocols. CCNA yatiri kuita before yaitonzi CCNA routing and switching. So ndo kwatinodhila nerouting and switching. With the new format yatanayo, routing and switching is still there, but there's a lot more. For example, PAN and network automation. What else? Network security hapo pichana, right? On top of routing and switching. So we are definitely going to be dealing in the routing and my routing protocols. I shall deal now Number one will be OSPF. Then we have other routing protocols, for example, BGP, more routing protocols. They are just responsible for routing, enabling routers to exchange routing information, compare path information, and select the best path to the destination. Those are routing protocols. Then we also have my service delivery protocols, which are used to for the automatic detection of devices or services. Example, EMA service discovery. I think you've seen DHCP, automatic assignment EMA IP addresses. We have DNS, translation EMA IP addresses to my domain names. Those protocols are service discovery protocols. So as you can see, we can group my protocols into those types. I think there could be more, but for now, let's start with those four: network, communication, security, routing, and service delivery protocols.